or a cluster, depending on your algorithm. Categorical values are both discrete and finite. So going back to the spam example, spam or not spam is an example of a categorical value. Another example could be the color of something, like red, blue, or green. The spam example and the color example are both nominal values because their order doesn't matter. Categorical values can also be ordinal, like small, medium, and large, meaning that there's a hierarchy present within the values. And finally, continuous values are simply values that are subsets of real numbers. So categorical data could be something like temperature, population, or age. So here's an example with a data set of some of the terms I just described. You can see row number 4 there is an example of a data instance because it represents a specific point in the data. The features at the top I've circled buying are what describe that instance. So this is a car evaluation data set that I'll work with throughout the presentation. And then also on the right there is our class. So the class in this case is a label. So a good tool for machine learning in Python is the scikit-learn module. It's an open source project that is constantly in development. There's a changelog on the website with everything that's currently being developed, and there's a lot of community support for it. It also has a few built-in data sets that are good for figuring out how scikit-learn works, and if you go on the website, it'll tell you what sort of algorithm they're good for, like classification or regression. The documentation is very thorough, and there are a few tutorials on the website which are good for learning. So this is the basic predicting and learning process, or learning and predicting process in scikit-learn. So the first thing we do is we create our model by setting a variable equal to an estimator object. So our estimator object could be something like a classification algorithm or a clustering algorithm. The next thing we do is we fit that model to our data to learn from our data set. So the fit function will take in the data set as a parameter and then the labels of that data set as another parameter. So if we're working with a supervised model, it'll learn the relationship between the data set and its labels. And if it's unsupervised, it will look through the data set for patterns without the labels and will extract them. And then finally, we can use what the fit function has learned, or what the fit function has had our estimator learn, and apply that to a new set of data. And that's just the basic learning and predicting process that you'll see throughout. Scikit-learn is very comprehensive of machine learning algorithms.